Hello, my name is Abhishek Ashok Burde. This is the experiment number 1. Here I am showing you the ARM Cortex, which is blinking. A blue light is blinking at a rate of 1 seconds, and this one is the main assembly code, and this one is the LED assembly code. First of all, I will going to explain you the LED assembly code. The code is written in ARM assembly language. It initializes the port F of the microcontroller for interfacing with LEDs and switches on the board. It also provides the functions for turning on and off LEDs and delaying the program execution for testing purposes. The code starts with some comments followed by defining the processor made as a thumb. And specifying the memory alignment as 2. It then defines the several constants to represent the memory addresses of a different registers in the microcontroller, and these registers control the operations of port F, including the data input or output, directions, alternate function selections, and more. The code then defines the several functions to be used later in the program. So after that, the first function is port F underscore init, where it initializes the port F. This function performs the several operations such as enabling the clock, unlocking the GPIO underscore CR register, disabling the analog functionality, configuration the port as a GPIO, setting the directions registers, enabling the digital input output ports, etc. It ends with the returning the function. Returning from the function. After that, there is a second function which is called as delay, where the second function takes the single argument in arrow and delays the program's execution for about 1 second, multiplied by the argument passed in arrow. This function performs a simple loop operation, decrementing the arrow until it reaches the 0 and then returns. Then there is a third function called as port F underscore output, where it takes an argument in arrow and returns it to the port F data registers. This function sets the output state of PF3, the LED on the board, and the function ends by returning. The code exports these three functions: the port F underscore init, delay, and port F underscore output, and some other functions that turn on and off LED lights like blue LED on, blue LED underscore off, similarly red and green, etc. Lastly, it defines some switches as well. It defines some constant to represent the colors of the LEDs like red, blue, and green, and the switches on the board such as SW1 and SW2, and the memory addresses of the system control underscore RCGC GPIO underscore R register, which is used to activate the clock of port F. Later, in the actual main assembly program, whereas main.assembly, where it first imported the functions from the previous led.assembly, these 4 different functions which will be later used in main.assembly program. Here in global.main, it's the start of the main function marked as the assembly code. After that, here is the start of the code where it call the port F initialization subroutine to initialize the input output pins of port F. In the my loop function, it moves the value of 1, 2, 3, 4 to into the register R5, then push the value of R5 onto the stack, and later pop the value from the stack to register R6. Later, it moves the value 3 into the R4. In the loop blue, a label indicating the start of the loop, it will call the first of all it will call the blue LED on subroutine to turn the blue LED. Later, it will call the delay, and then the blue LED will be off after 1 second. Similarly, by using subtraction function, it will subtract 1 from R4 register, where we previously initialized it as a 3. It then be any loop blue, it will compare it and that subtraction until it will subtraction should not be equal to 0, and again after that it will call the my loop function again, and it will initialize the R4 as a 3. So it's infinite loop running over, and later it's end of assembly code and end of line. That's the whole code we can available in the main assembly program. After that, it being built first, and then it is being flashed into the ARM Cortex, and as previously shown to you, the blue LED light is blinking at a rate of 1 second, because we have called only for a blue LED light in our main assembly program. So that's the total end of the video. Thank you for paying attention. Thank you so much.